Only mode.
Hello everyone, I'm Sean Esterly with the National Renewable Energy Laboratory, and welcome to today's webinar, which is being hosted by the Clean Energy Solutions Center in partnership with the International Energy Agency's 4E Implementing Agreement. And today's webinar is focused on the impact of phase-out regulations on lighting markets and the associated policy implications. And one important note of mention before we begin our presentations is that the Clean Energy Solutions Center does not endorse or recommend specific products or services. Information provided in this webinar is featured in the Solutions Center's resource library as one of many best practices resources reviewed and selected by technical experts. And you have two features for audio for the webinar. You may either listen through your computer or over your telephone. If you do choose to listen through your computer, please select the mic and speakers option in the audio pane. Doing that will just help eliminate any feedback or echo. And if you choose to dial in by phone, please select the telephone option, and then a box on the right side will display the telephone number and audio pin that you should use to dial in. And if anyone is having technical difficulties with the webinar, you may contact the GoToWebinars Help Desk at the number displayed at the bottom of the slide. And that number is 888-259-3826, and they can help you out there with any issues. And we encourage anyone from the audience to ask questions at any point during the webinar. We do keep the audience muted, so to submit your questions, simply type them into the question pane, and we can present those to the panelists during the question and answer session. And if you're having difficulty viewing the materials through the webinar portal, you will find PDF copies of the presentation at cleanenergysolutions.org/training, and you may follow along as our speakers present. And also an audio recording of the presentations will be posted to the Solutions Center training page within about a week of today's broadcast. And we are also adding the recordings to the Solutions Center YouTube channel, where you will find other informative webinars as well as video interviews with thought leaders on clean energy policy topics. So today's webinar agenda is centered around the presentation from our guest panelist, Stuart Jeffcott. And Stuart has been kind enough to join us to discuss the impact of efforts to phase out inefficient lighting in several countries and regions around the world. And before our speaker begins his presentation, I'll provide a short informative overview of the Clean Energy Solutions Center initiative. Then following the presentations is when we'll have the question and answer session where Stuart will address any questions submitted by the audience, followed by closing remarks and then a brief survey. So this slide provides a bit of background in terms of how the solution came to be formed. And the Solutions Center is one of 13 initiatives of the Clean Energy Ministerial that was launched in April of 2011. It's primarily led by Australia, the United States, and other STEM partners. Outcomes of this unique initiative include support of developing countries and emerging economies through enhancement of resources on policies relating to energy, access, no-cost expert policy assistance, and peer-to-peer learning and training tools such as the webinar you are attending today. There's 4 primary goals for the Solutions Center. First goal is to serve as a clearinghouse of clean energy policy resources. Second is to share policy best practices, data, and analysis tools specific to clean energy policies and programs. Third is to deliver dynamic services that enable expert assistance and learning and peer-to-peer sharing of experiences. And then lastly, the center fosters dialogue on emerging policy issues and innovation from around the globe. Our primary audience is typically energy policymakers and analysts from governments and technical organizations in all countries, but the Solutions Center also strives to engage with the private sector, NGOs, and civil society. And this slide highlights one of the marquee features that the Solutions Center provides, which is the no-cost expert policy assistance known as Ask an Expert. And the Ask an Expert program has established a broad team of over 30 experts from around the globe who are each available to provide remote policy advice and analysis to all countries at no cost. So for example, in the area of lighting, we're very pleased to have Gustavo Mañez Gomez, the Enlighten Project Manager on the United Nations Environment Program, serving as one of our experts. So if you have a need for policy assistance in lighting or any other clean energy sector, we do encourage you to take advantage of this service. Again, the assistance is provided to you free of charge. So if you have a question for our experts, please simply submit it through our simple online form at cleanenergysolutions.org/expert. or to find out more about how the Ask an Expert service can benefit your work, please feel free to contact me directly at sean.esterly@nrel.gov or at 303-384-7436. We also invite you to spread the word about this service to those in your networks and organizations. So now I'd like to provide a brief introduction for today's panelists. Mr. Stuart Jeffcott has been working in energy efficiency for over 25 years, and Stuart is currently the lead contractor for the IEA 4E's mapping and benchmarking activities, which seek to inform policymakers of potential product policy pathways to the benchmark of the performance of energy-consuming products across international borders. And however, over the last 15 years, much of Stuart's focus has been on assisting policymakers in the Asia-Pacific region develop product policy, particularly in the development and implementation of more efficient lighting. And so with that introduction, I would now like to welcome Stuart to the webinar.
Thank you very much, Sean. Let's start by making sure you can see my slides at your end. Can you see those, Sean?
Yep, they're up and all set.
Perfect. Thank you very much. Welcome to everybody that's joined. Thank you very much for making the time to hear about the outcomes from our study. I ought to start by thanking our hosts. That's Clean Energy Solutions Centre. They're very kindly providing their facilities to let us share our information with you. And particularly Sean and another lady that's working in the background, which you probably won't hear from, a lady called Heather. They've both been wonderful. One additional piece of logistics before we start, which Sean didn't mention. As you probably can tell, I'm a first language English speaker. I come from the UK, but I come from the north of the UK, so I have a slightly strange accent for some people. If you're a non-first language speaker and are having difficulty following me, if you just type into your chat box and tell Sean, he will try and sort me out. Okay, within the part of the agenda I'm talking about today, what am I going to cover? Well, firstly, I'm going to give you a very brief overview of the IEA 4E and its mapping and benchmarking analyses and the processes we go to, mainly because lots of people are interested in who funded a particular study and why. So I want to give you that background, and it will give you some idea of its independence. Then we'll get on to the main body of the report, the outcomes from the benchmarking study, and then, as Sean said, we'll go to a question and answer session. Hopefully I'll be able to answer anything you may raise. So let's kick off with the first of those. An introduction to 4E mapping and benchmarking. Well, let's do it in 3 stages. It sits under the umbrella of the IEA, that's the International Energy Agency, and it's an implementing agreement, which broadly speaking is a group of countries within the IEA that come together and agree to work together on a particular topic area. In this case, it's a bit of a mouthful, a cooperating program on energy efficient end-use equipment, hence they just call it 4E. But there's 12 countries involved, and I'll show you those 12 in just a moment. And all 12 members sit on this executive committee, and they then in turn establish the bits at the bottom which are called annexes. Think of these as sort of sub-clubs where people contribute money and resources to examine a particular area or a particular cross-sector issue that they're looking for as a group of national or international policymakers where they want some more information. Currently there's 3. There's one looking at electric motors and systems, one looking at solid state lighting, so LEDs, and one looking at this burgeoning new area of connected devices and networks, so smart products. The mapping and benchmarking activity used to be one of those annexes, but we've now been absorbed into the Central Management Committee because all the countries participate in mapping and benchmarking exercises. And then there's 1 or 2 one-off projects. So that's the broad picture of the umbrella we sit under. These are the countries that participate: Australia, Austria, Canada, Denmark, France, Japan, the Netherlands, Korea, Sweden, Switzerland, UK, and the USA. So a broad overlap with the Solution Centre. In addition to trying to source information from those countries and do analysis on products that are available in those countries, we also try and find information from other trading blocs. So in addition to our EU country members, we try and look at the EU as a whole. We look at places like China where we can, India, and sometimes South America. In this particular case, all the information relates to countries that are participants with the addition of the EU. But that varies product by product. So how the mapping and benchmarking activities work? What are they trying to achieve? Well, they're trying to analyze product performance between countries, so across national boundaries. Everybody does analysis when they make their own regulations and their own policy on what products they have, what technologies are emerging. But it helps policymakers if they can see an international picture of that kind of thing. So we're trying to identify which countries have better performing products compared with others, why that might be, what are the policy drivers, what are the cultural issues, and some areas that policymakers may wish to concentrate on, may wish to maybe shy away from, and some of the technology options they might be encouraging. So far there's been 14 products. Today you're going to hear about lighting, across the domestic appliances, so refrigerators, washing machines, air conditioners, dishwashers, all the way up to some commercial and industrial refrigeration systems, distribution transformers. The process itself is a three-stage process, and it's pretty much the same irrespective of product addressed. Varies slightly, but not too much. The first stage is product definition. Everybody thinks they understand what we mean by a dishwasher or a lamp or a distribution transformer. However, that understanding varies between countries. What performance characteristics are called, what the products themselves are called, how the standards are established, what's a typical size. A refrigerator in the US is about the size of a Swiss apartment. So what we try and do with the product definition is to create a standardized language that all our participants can understand and a frame of reference for them all to work in. And define the performance parameters we're going to look at and the scope of the analysis. We're going to look at big ones, little ones, particular sectors or whatever. The next stage is to create what's called a country mapping. Now this is a repository, a store for all the information on a particular country that will be used in the analysis. It includes historical and current product performance, the regulatory framework, labeling, MEPs, other policy interactions in the market, and some cultural and other relevant influences on product performance. That's used as the basis for the benchmarking analysis, which comes next. That takes all the data from the individual mappings that have been produced for each country and brings them together to an attempt to compare them and contrast the performance of products between countries. Now obviously the data we have differs, both in terms of its source and its quality, but also the framework that it's in. So some countries will measure different performance criteria than elsewhere. They'll use different performance metrics. They'll use different test methodologies. So we have to manipulate the data from the different sources and from the different countries to be able to compare it. That process we generically refer to as normalization. We try and normalize all the different data sources to one particular comparable basis. Our ability to do that varies between products. Fortunately with lighting it was certainly on the easier end of the spectrum. So that's the big picture of who we are and where we come from and how we do things. Let's now have a look at the benchmarking report itself. In this particular case, rather than looking at individual products, one CFL in the US is better than another CFL in Australia, we're looking at groups of products and how they're entering the market. But I'll come to that in more detail in a moment. We are looking at the impact of the regulations that are trying to manage the least efficient lighting in the market and generally try and remove that lighting. And it's updating a report from 2011. I will occasionally refer to the 2011 report because it had some more detail on specific issues. But in general, everything you see today will relate to the 2015 version. So, what was the report trying to achieve? Well, firstly, we wanted to give our policymaker funders the ability to see the difference in the phase-out regulations they have in place. Everybody thinks theirs is the perfect solution, and in lots of cases they are to local circumstances, but there are some significant differences in approach, and we wanted to highlight those to give them an understanding of where their regulations differ from elsewhere. We wanted to look at the type of products entering each market, so what are the proportions of sales of LEDs compared with CFLs, compared with halogens, compared with incandescent lamps, traditional incandescent lamps, and how is that changing over time? Because that should give us an indication of some of the major policy outcomes in terms of what products are moving into and out of the market. Looking at the longer term efficiency improvements, i.e. what people have installed in their home in the stock, we have a look at average efficiency of products entering the market. That's not a perfect metric, I'll come to why in a minute, but it gives an indication of the direction of efficiency improvements in the home in the future. And then finally we try to draw out of that analysis some of the key issues for policymakers, where they might consider modifying existing policy or maybe add additional policy to react to what's actually happening in the market from their first engagements. As I said earlier, it's not a direct comparison of this product is better than that product. It's looking at whole markets and impacts of the mix of products across markets. Excuse me. And we have put this boundary on. We're looking at products that are applicable to the domestic sector, so general service incandescent lamps, the traditional lamps, halogens, compact fluorescent lamps, and LEDs. Obviously, those lamps are used in other sectors, and some other lamp types are used in the domestic sector, but they're the primary lamps that are used in the domestic sector. So they were the focus of the study. So, data quality and quantity and availability. Well, if we just have a look at this slide for a moment, the countries on the left are those where we have data, and across the top are the key chunks of data. We have a great deal of detail within these boxes, but on a big picture, we have information on the policy, so regulations, labelling, that kind of thing. We have information on the sales over time of the different lamp products in those markets, and there's derivations of the overall efficiency of those products entering the market. We have developed within the mapping and benchmarking process a way of allocating reliability to that data, and that's a combination of the source data itself and any manipulations we have to do to it. Obviously, the more we play with data, the less reliable it comes. So in the graphics you'll see coming up, we have robust data which is pretty accurate. We're pretty sure that's representative of what it's displaying. Indicative, that gives you a pretty good idea. It's reasonably accurate and shows a good idea of the outcomes that are being presented. Illustrative, now that's a dotted line. Be slightly cautious of illustrative lines. I will take an example here. If you see halfway down the table you have Denmark, their policy information is the same as the EU, so we know their policy is right. However, a lot of their data is based on modeling. Almost all of the data is actual sales data from the market. Danish data has some manipulations internally within Denmark, and we had to do some too. Therefore, their data is little less reliable, and therefore it's included, but it has this illustrative declaration associated with it. One other thing to pick up here, US. We found it impossible to get pan-US data on sales of products. It is available in some forms for some products, but quite often it's either regional or doesn't address all product categories. Therefore, I'm afraid if you're interested in the US, you're going to have to use Canada as at least as a proxy. From the information we do have on the US, Canada is a reasonably representative mirror of the US. But Canada was able to supply data, we couldn't get it from the US. Okay, the process and a couple of cautions. We're looking at the efficiencies of lamps. We haven't looked in detail at the efficiency of the lamp in Canada compared with Australia, for example. We've used international averages. Because the difference between a CFL and a halogen is infinitely bigger than the difference between a 10-watt CFL in Australia and a 10-watt CFL in Canada, we've taken a global average of efficiencies and we've adjusted that for the years included in the study to show changes in the efficiency over time. I talked about the normalization process to try and make things comparable. Well, as a general statement, CFLs and LEDs, because they have electronic controls, voltage differences and things like that don't really make much difference. Similarly, the test methods are very similar. Around the world, they're all based on CIE standards, ultimately. So there's no normalization for those lamps. Where we have had to make a normalization is for filament lamps, which is incandescent and halogens, traditional incandescent and halogen lamps. And where we've done that, we've used an internationally recognized approach, which is IEC 60064, and we've backed that up with some empirical data to make sure that it actually gives a reasonably accurate conversion, which it does, fortunately. There's a number of cautions presented in the benchmarking report. These are the most critical ones. As I said before, we're looking at markets as a whole. So if you can imagine 100 lamps sold into Canada each year, 20% of those might be incandescent, 50% might be halogens, 20% CFLs, and 10% LEDs. We have that data by size, light output, stroke wattage, so we can break that down in detail. But it is looking at instantaneous sales in a particular year. It's likely that the efficiency of products installed is changing at a faster rate. So if sales are going up by maybe 5% efficiency improvement, stock is probably going up faster than that. It's related to the lifetime of the lamps and newer ones lasting longer than traditional lamps. Similarly, because of the metric we use in sales across markets, it's not a perfectly true metric. Lamp sales are falling because lamps are lasting longer and the replacement cycle is becoming longer. So direct comparisons between years isn't perfect, but it gives you a strong indication of what's happening. And finally, we haven't taken account of cultural factors in this case, at least to the greater degree we haven't. It's very difficult to quantify those. For example, in Asia, light quality is less important than it is in maybe Europe or North America. So the switch to CFLs happened faster. We haven't taken account of that in this analysis, but bear it in mind as we go along. I will mention it, particularly in respect to Korea. Okay, let's start off by having a look at the regulations themselves. On a big picture front, the graph for a start. Let me get my little highlighter up. The graph here shows lumen output, so how much light is emitted against how efficient something is, the efficacy requirement. And these lines on the graph are the minimum performance requirements, the MEPS level for all the countries listed on the right-hand side, which includes the lamp types and when the regulations come into force. I'm not suggesting you look at this in detail now. It's very hard to follow. At a very detailed level. I would recommend you go to the report if you're interested in this in real detail, because there's some important issues associated with this. But let's look at a big picture just for a start. As a general statement, irrespective of country, regulations don't ban a technology. They set a minimum performance requirement for a broad range of lamps. So it's not about necessarily banning an incandescent or banning a halogen lamp. It's about setting a performance requirement that if you can build a lamp of any type, this is the requirement you have to meet. Normally, regulations are implemented in stages. Larger lamps go first. Normally, there's a set of exclusions for lamps of a particular type or a particular function or under particular circumstances. And generally speaking, there are some extra performance requirements to satisfy consumers. This is a regulator intervening in the market, and they want to be sure that if they're making consumers change the product they traditionally wanted to buy, the product that it's being replaced with is at least as good in the consumer's eyes. So those requirements might be about additional performance parameters related to color, related to lifetime. So it's got to be this kind of color performance, it's got to last this long, it's got to give this kind of color rendering. And sometimes there's extra requirements. So in this case, I've just pressed the button, those extra lines appeared at the top. There are additional performance requirements for things like CFLs in Europe and Australia and Korea. And in the EU, there's something called covered lights. So that's anything that's not a point source light is required to meet a premium performance standard, broadly in line with CFLs a few years ago. So, big picture-wise, things are pretty similar. But if you start looking in detail, you'll begin to see some of the things are very different. Let's start with the overall regulatory approach. Again, I'm going to use my highlighter. I apologize for my graphical ability. But there's broadly three approaches to regulation. There's a curve. So let's look at this bottom brown one here. That's giving a continuous performance requirement across the lumen range, but at the lower end, the requirement is lower, and as lamps get bigger, they're required to be more efficient. That is typical of across lamp types. They're more efficient the bigger they are. The shape of that curve can be varied to meet whatever the particular lamp type or requirement is as those lamps get bigger. That's used in most countries around the world, China, Australia, Europe, Most countries adopt that. Korea adopt a stepped approach. Korea in this graph is green. So here is an example of one of the Korean regulations from a few years ago. As you can see, I'm drawing this. It's a stepped line, and it says from lamps with 200 to 700 lumens have to have efficiency requirements of 8 lumens per watt. Larger lamps, 10 lumens, and then those from 1200 lumens upwards are required to meet 12 lumens. So again, it's sort of reproducing this stepping as efficiency, as lamps get bigger, the efficiency requirement goes up. But in a bit more of a clunky way, and it doesn't necessarily capture all the energy savings in between, but it's very simple to understand. Now the US and Canada, which on this line, the US is always purple and Canada is always gold, but because they sit on top of each other, we've had to make it dotted. They have this sawtooth arrangement, and I'm trying to draw that now. Their regulations are created based on wattage buckets. So if, for example, a lamp is between 20 and 50 watts, then it has a certain efficacy requirement, then there's a step change between 50 and 100 watts and 100 and 150, whatever those boundaries are. However, the world's moved on now, and because policymakers in general are trying to move people away from those traditional 40-watt lamps, 60-watt lamps, 75-watt lamps, 100-watt lamps, and try and think in terms of light output, that's why we presented them in the same format based on light output rather than those wattage buckets. And you can see it creates some anomalies. It's possible that, let's see if I can change to red. If you're here, you would be non-compliant if you're producing that something like a 40-watt traditional incandescent. What you could do is actually increase the light output and the power consumption of a lamp and move here, and you suddenly become compliant. Not suggesting people would, but it creates the potential for some anomalies. And there's lots of other potential issues with that approach. So the US and Korean approach is very straightforward, and Canada, but it does present some issues. So that's a big picture on the regulatory front. Let's have a look at some other issues. Let's look down at this part of the graph just here. This is the bottom end of the spectrum. So in old-fashioned incandescent terms, this is sort of the 10, 20, 30 wattage lamps. As you can see, Australia's regulations finish here. US and Canada's regulations finish here. Korea's regulations finish there. European level regulations come all the way down here. It's not quite clear why people have different cut-off points at the bottom. These lamps are the same everywhere. Everybody has the same requirement for low light output lamps. Now the regular structures might drive that, but it's just a bit odd. Similarly up here, you'll see the US regs run out at about 2,600 lumens. That's, broadly speaking, 160, 170 watt old-fashioned incandescent lamps. And the previous Korean regs run out here. Again, why these differ is unclear. So let's clear those off. The stringencies. So what we're looking at, the actual performance levels. Look at all these different steps. There are some differences. Some of these are a standard lamp, some are on the clear, some on the covered, some on the reflector. But a lot of them are similar lamp types, but there's huge variations in the efficacy requirements between countries. And again, we're talking about the same lamps. Products exempted in some countries, the products exempted are a very small group confined to specific applications or specific functions. Elsewhere, broad swathes of products are excluded. Again, the applications are the same everywhere, the uses are the same, it's not quite clear why they're different. And similarly, the way the regulations are formulated. Sometimes it's in terms of specific product outputs, sometimes it's measured results, sometimes it's rated results, and they lead to different outputs. And it's very, very difficult for manufacturers to know those subtle differences between the markets, which makes compliance really quite difficult. Let me just clear all my markings and move forward. So this summarises it. Overall, they're pretty similar, but the regulatory approaches differ. Some of this sawtooth, some of smooth curves, the stringency, the levels are different, the range of light products and light outputs and products that are included within the regulations vary, exempted products vary, or have different performance requirements, and how those regulations are applied varies between markets. Now, manufacturers and regulators talk all the time about harmonization of requirements. Well, in this case, lamps are the most globally traded consumer durable. There is no bigger traded product that's durable in the world. If the political will exists and manufacturers are keen, alignment of these efficiency requirements and scopes and exclusions is technically very simple. And such alignment is likely to result in substantial energy savings, be that through adopting the higher performance requirements that are there, or simply by making better compliance. And that's the second issue of supplier understanding. At the moment, if you're a supplier in China, where most of people's lamps come from, it's very difficult to understand that Australia is subtly different from Europe, which is different from the US. What applies? What you do is make what you think. And that means compliance bodies have to pay more, consumers are less likely to be satisfied with the end result. There's potential for cross-border enforcement. If I identify a product in my market that's substandard and we have the same regulations, I can tell you, you can go looking for the same product. Or similarly, I can save you money by saying, this one's okay, don't waste your time, go looking elsewhere. So there's a potential for this increased global trade, and it's likely to reduce the cost to consumers. But this isn't happening. If anything, there's a movement away from this. There have been some efforts under the same umbrella that the mapping and benchmarking activities are happening. The 4E SSL Annex is trying to develop some performance requirements for LEDs and test methods for LEDs that are applicable globally. They're doing very well in that, but uptake so far has been relatively limited on the regulator level. And Australia and some of our member countries, for instance Sweden, have attempted to put forward proposals to the IEC for performance requirements for things like CFLs, but they've met with stiff resistance and they haven't been adopted. So the reason for those barriers are a myriad, but if policymakers and manufacturers really are interested in harmonisation, this is the product to start with, and maybe smart lamps, that this new generation of lamps that are coming onto the market, which potentially have enormous energy impact, that might be an area to start cooperating and trying to come up with an international approach. It worked with the new generation of TVs, for example. It worked with power supplies. Maybe smart lamps is an area where there can be some international collaboration to show it works, and then it can be expanded into these other lamp types where it should be easier. Okay. That's the regulations and some of the big takeaways for policymakers out there. what about the lamp sales? What impact has that had on the market to date? So what does this graphic show us? On the x-axis is time, so it starts in 1999 and runs through to 2013, and on the y-axis is percentage of sales of lamps that are incandescent. So let's take an example. As you'll see as we go through these slides, countries are always the same colour. So I'm going to pick Austria now because they're the easiest ones to see there at the top. Austria always this red colour. If you're interested in a particular country, for instance Canada, Canada is always gold. But let's look at Austria here for a moment and see what the graph means. In 2001, just here, of all the lamps sold in Austria in 2001, 90% of them were old-fashioned incandescent lamps. Over time, that's gradually been decreasing, and at the point when regulations began to come into force in various parts of the world, it had fallen to 73-75% of sales were still incandescent. So improving, but not great. But overall, there was this general trend to improve, going from 80 to 90% of incandescent by 2008, typically 60 to 75% of individual markets were incandescent lamps. Two anomalies on this picture. One is Australia. As you can see, they had a sudden fall in incandescent sales in 2007, 2008. Well, regulations weren't in force at that time, but the announcement was made that Australia was going to phase out incandescent lamps. As it turned out, it didn't do it by technology, it did it neutrally as others did. But basically, the announcement was made that it was going to change. And it rode a big environmental wave that was happening in Australia at the time to phase out lamps, and people naturally switched having heard the announcement. So they're the only country where an announcement appears to have made a difference. Everywhere else, nothing happened till the regulations came into force. Korea is this green bit at the bottom, another anomaly, but we'll come back to those in a short while. So what happened when regulations started to take effect? Well, the first regulations were in Australia and the EU. Australia pretty much regulated everything in 2009. The EU did it phased 2009 to 2012. And as you can see, it's resulted in a precipitous fall in sales of incandescent lamps. This is what policymakers were hoping for. This is what they were expecting to happen. Looking at a couple of things in detail, we have Australia. They continued their fall from announcement to where the regulations came into force, carried on down. They've been the best performers. Overall, the EU, which is the brown one, has been falling in line with the regulations, and the EU countries around it, so Austria, UK, and Denmark have been following a broadly similar path. This big fall in incandescent sales in the UK. The UK is a blue line with a big V sign down. That corresponded with an enormous push in CFL giveaways from utilities under a utility program in the UK, which was brought to a halt in 2010. So it went down very rapidly and then back up again as soon as that giveaway finished, and reverted to type like the rest of Europe. Austria is lagging very slightly up here, and the V at the top was a big consumer backlash against the regulations. There was press and public reaction was negative at the time when the regulations came into force, and there was a big stockpiling of incandescents, but that's been offset over time, and they are again now joining the rest of the EU in this precipitous fall. So good. Where regulations have been enforced for a while, things have been happening. What else? So Korea, down here at the bottom, their most recent regulations came into force in 2008 and then again in 2012. They were the first country to regulate seriously in 2003. Not particularly ambitious at that point. It didn't take any particular products out of the market, but it signalled early on their intention, and they have been the best performers overall. As you'll see in a moment, they have the biggest uptake of CFLs. That's partly due to their Asian acceptance of light quality being different to elsewhere, but also this signal that the regulator is serious. And elsewhere, Canada's the gold one I told you about. They had a pretty big fall in incandescents over time, that's right. That related to a big CFL push under something called Switch and Save. That program pretty much ran its course in 2007, 8, 9. It's still ongoing, it still promotes LEDs but on a much smaller scale. So incandescents have had this fall, but it's then leveled out, and since policy intervention has calmed down, it's flattened out, and regulations are coming into force around about the time this data runs out, but there's a little bit of indications going down, but not a huge amount. And finally, Japan. Let me clear Japan on. Erase it with the side. This is Japan. Japan's the black line, always the black line. There's some uncertainty about Japanese performance, but Japan is unusual in being the only country with no regulation. It has a voluntary agreement with industry to stop using incandescents, stop producing incandescents, but that's quite a small impact because most of them were imported anyway. What really was the driver in Japan was at 2011, there's this sudden downturn. They had their tsunami, and the disaster associated with that led to a national power shortage and a big change in the cultural perspective of the country, and a big switch resulted to more efficient lighting. And we've got some more recent data than this since the report was published, and that line carries on going down. So we can see where regulations are in effect. There's been a huge impact. Places like Canada where they're not there yet, there's no real step change. So good. The policy implementation appears to be working. It's taking the worst performing lamps out of the market. We can see this clearly by looking at the EU. This is incandescent sales in the EU by year, by lamp type. So this is drawn from the EU mapping report, where there's much more detail on an individual country. You can go and look at that. There's similar things for other countries. You can see the step down, firstly from about 500 million incandescent lamps sold in 2007 to about 50 billion in 2013. So a 10 times reduction in the amount of incandescent sold, which is a good thing. It's what the policymakers wanted. And you can see the larger lamps are being removed from the markets first. 2013, after the point where most of these lamps should be removed, there's still sales. Partly that's to do with exempted lamps, and partly it's to do with legacy sales. If you had lamps in your store before the regulation took effect, you were still allowed to sell them. So that will continue going down, but it will tend to flatten out now. So good. We're getting rid of the worst performers in the market. So what's that mean in terms of improving efficiency? Well, looking at those countries where regulations are in force or were anticipated, well, typically there's been an improvement. In this area of the graph here, we were looking at lamps, average lamp sales across all lamp types, CFLs, LEDs, incandescents, of efficiency broadly in the 12 to 15 lumens per watt range before regulations took effect, and that's now picked up, and we're up here in the 17 to 20 lumen per watt range. There's that strange peak in the UK to do with that short period where there was a CFL, huge push, but in general it's reverted to tie. So there is an improvement in the average efficiency of lamps sold, but not the big step most regulators were expecting. Incandescents have fallen down. We expected a move to CFLs and LEDs, which would have driven this up much further. From CFLs, LEDs are in the 50, 60, 70 lumen per watt category. Why hasn't this graph been pulled up further? Well, other countries have managed a bit better, particularly Austria and Korea. Australia rode a bit of a wave of environmentalism in Australia, tailed off that, but they engaged very closely with their stakeholders. They did lots of work on the ground, which means they managed to get a better take-up and are doing better. They doubled their efficacy. They went from 14 to 27 lumens per watt. And Korea, it's continued its upward trend. It's doing remarkably well compared with elsewhere. Its regulations have been very successful, and then combined with its cultural situation, it's managed to drive efficacy levels to twice as good as Australia, which is the second best, and 3 times as good as the rest of the world. So, big fall in incandescent. In general, a slightly disappointing increase in efficiency. So why is that? Where have all the lamp sales gone? Let's have a look at CFLs and LEDs. So again, this looks a bit cluttered, but let's do it in stages. This is the same graph as we had for incandescents, but in this case it's CFLs. We have time along the bottom, and then the percentage of all sales of the CFLs. Take that off. So again, to take an example, let's take Korea because it sticks out at the top. It's relatively easy. In 2006, about 55% of all all lamp sales in Korea were CFLs, and that's risen a little bit of a step, but now that's 70%. So what's happened elsewhere? Well, there has been a pickup in sales, but as a general statement, it's been pretty disappointing. Australia's done very well. It's had this big jolt associated with the announcement. Then the regulations came in force into 2008, and it's managed to stay at broadly that level. So it's managed to drive CFL sales up to about 30% of the market. In Europe, there was this pretty broad flatlining around 5%. Regulations came into force. As a general statement, there was a bit of a peak up to 2010, but they've sort of fallen down. Individual countries vary a little bit. We've got this downturn in Austria where we had the negative impact, and this bump in the UK, which was the big CFL push by utilities. But in general, it's followed the overall EU line, bit of a bump, and back down to 15%. So good, it's gone from 5% of the market to 15% of the market, but not the huge step change that regulators were expecting. So have markets gone to LEDs rather than CFLs? Well, this is LED sales. They've received lots of hype. They are certainly exploding on the market, and from 2008, where there was broadly no noticeable sales in the market, there's been a big growth. But in 2013, we're still only looking at 3 to 15% of any market. In general, much closer to the 5 to 10%. So lots of hype, but as yet, they haven't penetrated the market. So what has been happening? This is the same graph, but looking at halogen lamps. So when we had this broad swathe of pre-regulation, markets were somewhere between 15%, 20% halogens, down to what's that, 5, 6, 7, 8%. And then regulations start coming into force just about here. What's actually happened, rather than customers migrating to LEDs or CFLs, which is what regulators would have hoped, what's happened is there's been this explosion in halogen sales. Now, halogens are only slightly more effective, slightly more efficient than incandescents in general. You know, we're talking about a 10, 12, 13 lumens per watt move to a 14, 15, 16 lumens per watt in performance. So what we've seen is halogens beginning to take a big share of most markets, and not the switch to CFLs and LEDs that we're expecting. Now, we can see this much better if we combine incandescent sales and halogen sales together. So, in fact, we've just taken LED and CFL sales from the market. What we see is those countries where regulations have come into force around about 2007, 2008, there's been a small reduction in combined halogen and incandescent sales, but broadly speaking, it's only gone from sort of 90, 95% down to 80, 85%. And that explains why there's only been a small uptake, a small uptick in the overall efficiency of lamps sold. There was a big fall in incandescent sales, but there's really just been a migration to halogens. So the EU stabilising about 80% of the market. Canada regulations haven't kicked in yet, but it appears to be following broadly the same path. This bit here was where they were pushing CFLs very hard, but what's happened is there's been a migration back to halogens, and as far as we can see, CFLs are now on a replacement track, and it appears Canada is going to join the EU and most countries where regulations are enforced now, where halogen is going to become the default choice. Australia doing better than everybody else, but nevertheless is beginning to flatten out, with incandescents and halogens becoming the default choice. So the big message for policymakers here: there needs to be a relatively rapid policy intervention to maintain this improvement in the market and prevent halogens becoming the new default choice for consumers. Most countries faced some kind of political backlash from their regulatory introductions. If consumers get used to halogens as the default new choice, you're going to face that again if you ever try to drive to these new performance levels of CFLs and LEDs. That's going to be a challenge to overcome if regulations aren't addressed soon. So that's data on sales in the market. Impact is happening. Incandescents are reducing. It's not leading to the improvements in efficiency regulators will have. Additional policy may be required. So a quick deviation into another outcome from the study. Well, for us to do our job, we needed lots of data. I said at the start, sales were not a perfect metric for this. What they do is allow you to see trends in the market, whether a type of product is getting around regulations, any new technologies coming along. So it's a useful thing for regulators to know about. And I have to say there's limited market knowledge out there. Our partners put in an enormous amount of effort to get the data we presented. Some of it is new to policymakers. They didn't have this data before we gave it to them. So we're helping, but it's worthwhile investing in that data. And improved in-home application and usage patterns. Sales are useful for big picture trends. They don't tell you the whole story. If sales of CFLs and halogens are going up, so CFLs and LEDs are going up, but they're being installed in cupboards and garages where use is very low, impact on consumption is going to be marginal. If the reverse is happening and they're going into high use applications, it's going to be significant, even if their sales are relatively small. Unfortunately, very few people know that. Finding the information on in-home application is hard. And some regulators have spent a lot of time doing it. California, for instance, has some really good information on this. Australia has invested, the UK has invested, but nevertheless they don't map the entire market. And there's an opportunity for regulators to invest in this, and people that want to support regulators to support them in that investment. And that would be really useful, would improve future policy and compliance. So, key issues from the report as a whole. I haven't managed to go into any level of detail, but the things to take away. There has been a substantial reaction in the market from regulations. There's been a precipitous fall in sales of incandescents where the regulations have kicked in. Canada appears to be following a similar path. The US, we assume, will be something similar. Alas, there's not been a similar uptake in the efficacy as expected in most policymakers and in their projections of savings from the regulation, because there's been a significant migration to halogens. Policymakers really want to consider urgently intervening in the market to stop those halogens becoming the default choice. The EU is nominally doing so through their what are referred to as Phase 6 regulations, which should come into force next year. They're currently under review. There's a suggestion they may be pushed back. The EU needs to think about that seriously. Similarly, the US has some planned regulations for 2020. They might want to consider bringing those forward so they don't come across quite such a big jolt to the consumer. The market momentum, the market change continues much more rapidly. Korea, although they have some unique cultural situations, does show us that regular revision of their performance requirements does lead to rapid market change. Something I highlighted on and off on the way through, for instance, Canada's improvement in CFL sales, but then fall off. The UK's big push for CFL programs and then fall off. Non-regulatory interventions in the lighting market do seem to work, but only in the short term. Very quickly after the intervention, the support, the policy, whatever it is, ceases, the market seems to revert to its original state relatively quickly. So if policymakers are considering or currently implementing non-regulatory interventions, things like Energy Star, that kind of thing, if you want them to continue, you have to continue that intervention. If you stop, the market returns relatively quickly. And this final thing that I went into a bit of a divergence about, better market knowledge and usage data is really important to help develop better policy, monitor the implementation of the policy, and do things like we've just done in terms of measure the impacts. Okay, I think that takes me to the end. What I have here is a couple of websites. You can get the mapping and benchmarking reports, all our outputs from that second website, but as you can see, the address is rather long, so maybe use the top one, www.iea4e.org. That takes you to the 4E site. Click the mapping and benchmarking tab, and then you'll be able to download things direct. You can write to me, that's my email address at the bottom, or I'm sure Sean or his colleagues will be happy to funnel through to me. So, questions. Maybe I hand back to you at this point, Sean?
Yes, thank you, Stuart, and thank you for the presentation. And just a reminder to the audience that if you do have any questions, those can be submitted through the question pane on the GoToWebinar window, and I can ask them to Stuart from there. And so we'll move on now to the question session. And the first question that I have for you, Stuart, asks, it's in relation to slide 14. Do you have similar breakdown of sales by product size for other products in the EU, such as CFL and LED, and for other countries?
That's a pretty decent question. Would it be possible for you to just hand control back to me for a moment, Sean?
Oh, yes.
And I'll take it back to slide 14 and see what we're talking about so people know what we mean. So this was slide 14. Somebody's picked up on incandescent sales, and you can see how sales have changed over time for different product sizes. The simple answer to that question is yes, we have mirror data for this for CFLs and LEDs and halogen lamps and actually fluorescent tubes within the EU. Well, the information I presented here for all the lamp types was a summation of this data. For all countries we studied, we have this data broken down by similar sizes, by similar time frames. So yes, we have it for all the different product types within the EU and mirror information between countries. And if I can just switch to my browser view for a minute. Let me go to the browser. Nope. This is the 4E website. This is the mapping and benchmarking website, and you can see the different products. If I select domestic lighting, you can see the publications. At the top here we have the benchmarking report we talked about today, but down here we have the individual reports for each country. So I showed you the EU one. That was an output from the EU. We have the same for Australia, Austria, Canada. Each country that appears in the report has a similar breakdown of products. So yes is the answer to the question. And you can take control back if you'd like to, Sean, or you can leave it with me.
We can leave it there for now in case another question is related to the slides. And so we had a few more come in from the audience. The first question I received asked, is part of the explanation of sales trends related to the price of lamps, and will falling prices of LEDs change the picture absent additional regulations?
There is certainly a linkage between price and sales, absolutely. The fall in LED price is going to be a big factor in that switch. We weren't able to track price simply because the range of lamps we were picking up information for was enormous. And going back to that shortage of market knowledge, nobody actually knows it. There are some commercial reports that are available for some markets, but as a general statement, their coverage is actually pretty small. And the price of products, particularly LEDs, is changing rapidly. So the simple answer to the question is yes, LED prices falling is going to drive the markets in that direction, and it's going to encourage take-up of those products and help with the regulatory framework that's in place. To what degree, I don't think anybody knows, and to what degree the prices will change. They're continually going down, but at some point that's going to stop, and there's very different pricing strategies in different parts of the world. I currently live in France, and I can buy a product in France, and if I go to the UK, exactly the same product is half the price, and in the US it may be half the price again. So it depends partly on manufacturer's pricing strategy and partly how effective this global trade is in competition and allowing products into markets. So I sort of skirted the question. But prices are impacting the market. I'm going to hold my hands up and say I don't know what degree. We couldn't look at that. I don't think anybody really knows. So yes, it is impacting. It will impact differently in different parts of the world. To the degree we just don't know yet.
Great, thank you.
Sean?
Yeah, and moving on now to the next question. It asks, should countries or do countries have technology-specific regulations instead of efficiency-based benchmarks? And what is the main driver for the shift to halogen? Is it price or preference in terms of its similar appearance to incandescent lamps?
Right, I'll do the first question first because it's easier. Do any countries regulate by technology? As a general statement, no. None of the countries we looked at regulated explicitly by technology per se. China is a bit of an exception. It wasn't included in the study, but I worked there a great deal. I helped with their phase out. In effect, they regulated incandescent lamps specifically rather than all lamps across the market. But as far as I'm aware, that's the only country that specifically sets their MEPs based on technology type. Having said that, there are increasingly regulations that apply to specific technologies. If you look at the EU, it has some regulations that if it's an LED, it must comply with this performance requirement. If it's a CFL, it must comply with this performance requirement. If it's a reflector lamp, it must comply with this performance requirement. But generally speaking, they're about, there is an efficacy requirement there, but they're very much about making sure that the consumer's getting the service that they're expecting from a particular light source as the market evolves. So, yes, some technology regulation, but it's limited and quite focused. Now, on the second part of the question, much tougher, a bit like the question on price. We don't know for sure. Why are people going to halogens? Partly it's price related. Partly, I'll take my mum, as a classic European consumer, a halogen lamp looks pretty much like the lamp she's always bought. It's sold in broadly the same way. You know, I have a 60-watt lamp. This halogen says it's the same as a 60-watt lamp. It looks the same as a 60-watt lamp. It's a bit more expensive, but it's not very much more. I'll buy that. So partly perception, partly cultural preference, partly history, and partly price are all drivers. That mixture varies between countries, but it's likely that's going to continue until there's some kind of regulatory imposition to change that. As I say, the 2016 European regs should, if they're not delayed, which looks likely, the American 2020 regulations with their backstopping 45 lumens per watt would do it, but might be a bit late and you might get quite a lot of political backlash in the US. Australia are looking at their regulations now, but pretty certain without some kind of push, the cultural price, traditional drivers are going to hold halogens. The balance varies between countries, but I don't think it really matters. It applies everywhere to some degree. Did that answer the two parts of the question appropriately, Sean?
I believe so, Stuart. Yeah, thank you.
Just to be aware for you, Sean, you're a bit quiet at my end. I think you might be for everybody else too.
Oh, sorry about that. I'll move the telephone a little closer.
That's better.
That should help. Next question for you, Stuart. Points out that in the U.S. there was a political pushback against the government eliminating incandescent lamps. Has there been similar pushback in other countries that you're aware of?
Absolutely, and absolutely everywhere. If you remember, oh, I still might have control of the slide. I do. You remember this little bleep in Austria? Austria was a particular example. It happened in Germany. We haven't got the data for Germany for all year, so it's not included on this graph. But large swathes of Europe had a real pushback. A populist uprising, if you want to call it, driven a lot by the media, anti-regulation. It happened here. To some extent it happened in Australia, but they were able to ride it better. They had also the advantage that they engaged in their stakeholders much earlier. They got very close to them. They explained a lot to the market. So Australia fared better. Even China saw a little bit of bounce back. The UK, it appears the UK went in the opposite direction to Austria, which is true, but it was due to this strange CFL intervention related to utilities. But in terms of media coverage and political challenges, absolutely there was a pushback. But as a general statement, that has waned significantly. Most regulators now have managed to go through that sometimes short, sometimes long pushback period, and consumers are just getting used to the new changing situation in the market. So yes, initially almost everybody had pushback, but if you stick with it, you get through it. But that's the key message coming from this. If the momentum of change that consumers are now expecting with this changes to halogens and LEDs coming in, if that momentum stops and halogens do become their new default choice, it's likely that regulators are going to face exactly the same challenges again with their next round of regulations. Whereas if they keep the momentum going, consumers are now attuned to the fact that things are changing. I need to be looking for something else. They can do it now. Keep the momentum going, or that backlash is going to happen again, and probably worse next time round. We've done it once. Why are we doing it again? Why didn't we fix it first time?
Great, thank you.
Sorry?
And the next question from the audience asks, how could, quote, light systems, unquote, be regulated in the future, also with efficacy?
It's a challenge. Everything you've seen today is related to the lamp itself. We are moving into a brave new world where the lamp and its control system may or may not be linked on an individual level. Lamps may or may not be linked together. And on a household level, they might be controlled at a distance from a telephone. I don't know is the answer to that. It's quite simple. I don't know. I don't think anybody knows yet. The EU has just commissioned, I say just about 6 or 8 months ago, commissioned an organisation called VITO to look at exactly this. How are they going to begin to regulate lighting systems? It's been done for a while at the commercial and industrial level through building regulations. But now we've got these different types of lamps entering the market. The system is coming down to the home level. And I don't think anybody knows. I would encourage you to look at what's happening in the EU. Certainly some of the more future-looking governments around the world, national or local, for instance, California are looking at this issue. But as yet, there's no resolution. Nobody actually knows what the lamps will look like in 2 or 3 years. Will everything be controlled by a phone, or will it still have a switch in the wall? Will they be talking to each other, or will that just be a fad? Are we stuck with halogens, or will there be this revolutionary moment where the refrigerator is controlling the light bulb? We don't know. It's a transitional period. It's one of the reasons why that market data is critically important over the coming period, and government and NGOs need to be investing in that to find out what's happening, to make sure technology doesn't run away. So again, I haven't really answered your question. I don't know how they're going to regulate systems into the future. People are looking at it. Keep your eyes open. There will be an attempt to do it in the next 1 to 2 years, or at least to map out an approach to doing it. Whether that's going to be effective, we have to sit and wait and see, I'm afraid.
Great, thank you, Stuart. And we have a couple questions left, but we are running out of time, so these might have to be a little briefer. The first question is, was the special purpose loophole in the EU regulation taken into consideration in this impact assessment? For they give the example, you can still buy 100-watt incandescent lamps sold as heat ball or rough service, etc., in the majority of EU countries.
Was it taken into account? It was. We didn't look at it separately. Where's that EU picture? This part just here. Partly it's legacy lamps. Partly it's people getting around the regulations. So it is happening. There are notable efforts to get around regulations everywhere. Canada did have a short period where modified spectrum lamps were appearing on the shelf in a format that made consumers believe they were just incandescent lamps. So yes, everybody has some issues with so we call regulatory avoidance. That's why market monitoring is important, and that's why there's some of these legacy sales in the EU. It's happening more in some countries than others. Australia in particular does quite well in keeping theirs down. They have a registry system, they require product registration, they do in-store monitoring, and they do testing. So really depends on how robust your regulations were for a start, and whether you continually monitor your markets, which maybe some of the EU doesn't do particularly well.
Thank you, Stuart. And one of our attendees is wondering if you know whether or not India has similar regulations established.
Oh, that's a difficult question. India does have some. I don't remember all the details. India certainly has extensive regulation related to LEDs, some regulations related to CFLs, but I don't think it actually has a minimum performance requirement for all lamps across the market. So I don't think it has MEPS, no. They certainly looked at it for a while, but I don't think there is a requirement. I won't guarantee that, but if you contact the Indian Lighting Association, they're actually pretty good. They'll be able to get back to you. But if you really want to know and can't get hold of them, just drop me an email and I'll find out the actual answer for you.
Great. Thank you once again, Stuart. That is the final question that I've received from the audience. So at this point, we'll move on quickly to our attendee survey. We just have 3 questions for our audience today that helps us evaluate how we did and improve for future webinars. And the first statement is, the webinar content provided me with useful information and insight, and just mark whether you strongly agree, agree, not sure, disagree, or strongly disagree. And the next question is, the webinar's presenters were effective? And then the final statement, overall the webinar met my expectations. Great. Thank you very much for answering our survey. And on behalf of the Clean Energy Solutions Center, I would once again like to thank you, Stuart, for your presentation today and for your time, and also to our audience for participating in today's webinar. We very much appreciate everyone's time. I do invite our attendees to check the Solutions Center website. If you would like to view the slides, you can also download them. And within about a week, we'll have posted the recording of today's webinar to the website as well. Additionally, on the Clean Energy Solutions Center training page, you will find information on upcoming webinars and other training events. And just a reminder, we are also posting the webinar recordings to the Clean Energy Solutions Center YouTube channel, which has several other videos, clean energy policy-related videos as well. So I encourage you to check that out. We also invite you to inform your colleagues and those in your networks about Solutions Center resources and services, including the no-cost policy support. So with that, I hope everyone has a great rest of your day, and we hope to see you again at future Clean Energy Solutions Center events. And this concludes our webinar.